So related to the arithmetic sequences are something called an arithmetic series. Now a series is based on a sequence, but we're just changing all of those commas then to plus or minus signs. So it's going to be the sum of all of the terms in the sequence. So we can write out the sequence, and it has commas between each element. To change it to a series, we just then replace those commas with plus signs, and then we can add those terms up. So when we're dealing with the arithmetic sequence or series, those are of course based then on just an arithmetic sequence, which we looked at last week. So as with the sequences, there's a common difference between then the successive terms, the t1, the tn, all of those will be the same. So if we look, for instance, at an arithmetic sequence, 2, 4, 6, 8, 10, we have a common difference of 2, first term of 2 as well. The corresponding arithmetic series then would be written 2 plus 4 plus 6 plus 8 plus 10. Again, just changing those commas to addition signs. And then we can also solve these. So if we just add up those 5 terms, then we get a value of 30. Now for these relatively short ones, it is probably best just to add those together. And then you can do that fairly easily just in your head. And put those together. But if you're looking at, say, the first 20 terms or the first 100 terms of these ones, that does get a little bit time consuming. And so we do have 2 equations that'll help shorten that up. So Sn equals n over 2 times t1 plus tn. And then a related equation, n over 2, 2 times t1 plus n minus 1d. And we'll look in just a moment where that one comes from. Just in terms, though, of your variables, the tn is the same as it was with the sequences. So this term here as well, the tn equals t1 plus n minus 1d, that's that general term then for your sequences. That also applies to all of these as well. And the variables are the same. So tn is just the value of that nth term, t1 is the value of the first term, n is the number of terms, and then d is that common difference, which will always be there in the arithmetic sequences and series. What we're introducing here now is this Sn term, which is then just the sum of a number of terms. So if you want the sum of the first 10 terms, this would be S10. The sum of the first 20 terms, S20, and on from there. Now these 2 equations are actually exactly the same equation. We're just substituting this general term into the first one. And so if we look at this first term, we have Sn equals n over 2 times the t1 plus tn. But tn is equal to t1 plus n minus 1d. And so this can be written as n over 2. And then I get t1 plus, and then just writing this one in, I get a second t1 term, and then plus n minus 1 times d. And so my Sn is just going to be then equal to n over 2, and then I'll get 2 times t1, so I'll just add those 2 together, and then plus the n minus 1 times d. And that'll give us then that second equation. So these 2 equations really are the same equation. This one, though, is good if you know what that tn term is. So if you know the nth term, then this is a bit shorter to use. If you don't know what that tn term is, but you know, say, the number of terms and the common difference, then the second form is a bit easier to use. But now you don't need to memorize those 2 sum equations. Do watch on your formula sheet that you're taking them from the right section. So we are looking at this arithmetic sequences and series section on your formula sheet. And then you have those 2 for the sums. The t1 plus tn, and then the 2t1 and minus 1d. I do note again that this equation over here is exactly the same as the other one. The only difference is that instead of writing t1, we're using a for that, so it is a slightly different notation. But really, we're going to be using t1 for all of those. We looked at that last week with the sequences then as well. So this is just really redundant, so you can really just ignore that if you like. We'll be using these 3 for all of those. So for these ones, if we're looking for the first 60 terms, we'll want to use one of our equations to solve for those, just because adding up 60 terms is going to be a bit time-consuming. So for this one, remember, we can get our common difference just by subtracting successive terms. So 8 minus 5 is 3, 11 minus 8 is 3. It's a good habit to just do a couple of those ones there, just to make sure you're dealing with an arithmetic rather than, say, a geometric sequence. So watch that you're doing that. But that's just the difference between any 2 successive terms. Our t1 then, of course, is equal to 5. And then we have our n value, which is the first 60 terms, so n equals 60. So for this one here, we'll want to use that 2t1 plus n minus 1 times d, and that'll give us then the sum of S60, so the sum of the first 60 terms. N is going to be 60, so 60 over the 2. 2 times the t1, which is going to be 5. And then plus, we have 60 minus 1, and then times that common difference of 3. So we put all of those values in. That'll give us the sum of the first 60 terms, which is S60. And that gives us then 5610, or 5,610. So please just pause the video here for a moment, give part B here a try. Once you've got that, restart the video and see how you did. Okay, so for this one, our common difference is going to be -2. So I have -8 minus a -6, -10 minus a -8, and just subtract those successive terms, and then you can come up with your common difference. So I have a d of -2. T1, of course, is equal to -6, and as before, I have 60 terms, so n is equal to 60. I have the same set of variables, so I'll use the same equation. So here I have s of 60 will again be 60 over 2. My t1 and my d, though, are different, so I have 2 times the -6, and then adding to that the 60 minus 1, and then times the -2. So watch your signs with these ones. I have this one, s60 will equal -3900. Now for these next two, you'll notice that we do have the nth term here, and so that t1 plus tn sum equation is going to be the one that we want, but we don't know what n is, and regardless of which sum equation you use, you always need to know what the n value is. So for this one, we can find that just using the general term equation. So tn equals t1 plus n minus 1d, and that's the equation for the general term, which we had last week, and we can use this then to find our n value. Once we know n, then the sum will be fairly straightforward to solve. So I'll get 201 for my nth term, and again, we don't know what that one is, but we'll be looking for that. T1 equals 5 for my first term. I get this n minus 1. Again, for my common difference, 9 minus 5 is 4, 13 minus 9 is 4, so I have a common difference of 4. So I'll move the 5 over with subtraction. That gives me then 196 equals n minus 1 times 4. I can divide the 4 out on each side, and that gives me then 49 equals n minus 1, move the 1 over, and I get n equals 50. And so I have 50 terms then in this series. To find my sum then, we could use either one because we know enough information for both, but the n over 2 times then the t1 plus tn is going to be my shorter solution, so I'll use that. So we're looking for s of 50. That'll give me 50 over 2, and then I'm multiplying that then by the first term, which is 5, plus the last term, which is then that 201, or the 50th terms, which is what I'm looking for here. So s of 50 then is just going to be equal to 5,150. So I'll just pause the video again for a moment, give part B a try, and then come back and see how you did. So we'll use the same procedure for this. We'll use that tn equation then to solve for the number of terms, and then we'll find then the sum of the equation. So do watch your signs when you're solving for these. Your n value has to be a positive integer. So if you're solving for n and get a decimal, or if you're solving for n and get a negative sign, then just make sure you always go back and check your work because you have a sign error somewhere then along the way. Once we have our number of terms, then we'll use the same equation here. Again, both of those sum equations would work in this case, but since we know the last term at -171, this will be a slightly shorter equation to use, and so that's the one we're going to look at here. And so for your final sum, you get -3,738. So for this next one, we're going to have to do a system of equations. So we have t20 equals 156, so we can use the equation for the general term to set this one up in terms of t1 and d. And then our s30, we can set this equation up also in terms of that same t1 and d. And if these are the same series, the t1 and d to generate the 20th term, and the t1 and d to generate the sum of the first 30 terms should be the same. And so we'll set up our general term equation as first. So here we're looking for t of 20, and so that's going to be equal then to the first term plus that n minus 1, so 20 minus 1, times the common difference. Now I don't know what t1 and d are, but I do know that t20 is equal to 156, so I can sub that one in and then isolate my t1 then in that equation. Now I can do the same thing with my S30 equation, and so I have S30 is equal to n, which is 30, over 2, and then I'll multiply that by 2 times t1, which I don't know, plus the n minus 1 times d, which I also don't know, but is going to be the same as the t1 and d in this equation. So I know that S30 equals 3600, and so I'll set that one up. And then I'll isolate T1 again, and that will allow me then to generate a system then in terms of T1 and D that I'll be able to solve. So then once I have my two equations isolated for T1, written in terms of D, then I can make those two equations equal to each other. That will allow me to solve then for my common difference D, and I can put that common difference back into either one of those equations to resolve for then my T1. So then what I'm going to do to solve this one is I'll take this 2 and I'll multiply that 2 to the other side. Now don't forget that 2 has to multiply through both of those terms when I do that, but that will allow me to clear my denominator, and then I can fairly easily isolate D from there. And now once I've isolated my D value, then I can put that fairly easily back into either one of those equations. I'll use this one because it's a little bit shorter. That'll allow me to solve for then my first term. And so I have a first term equal to 4 and a common difference of 8. So for this last one, we're looking for the sum of the first 75. So that's going to be my n value, positive multiples of 3. And so multiples of 3 are just something where I can go 3 times some integer to generate that term. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. And so we can see that my first term has to be a 3, and that they're going up by 3's in each case. So what I can say from this is T1 is equal to 3, because that's going to be the first positive multiple of 3. But also I can say that my D value is also going to be 3. Because if I look at the multiples of 3, I have 3, 6, 9, 12, 15, and so on. And so all of those, if you set those up, you can see are going up by then that value of D equals 3. So adding 3 in each case. Now I'm looking for the first 75 of those, so I see that n is equal to 75. Now I'm looking for the first sum of those, or for the sum of those 75 terms, and so that's going to be an Sn. So S75, and that'll be then 75 over 2, so always that n over 2. Now because I know my D value, my T1, I'll use that 2 times T1 equation. So 2 times that T1 of 3 plus n minus 1, so 75 minus 1, and then times that D value of positive 3. And so S75, when I put all of those values in, will end up being 8,550.